Hey, what's up? It's your old pal, Mr. Cook. We're going to do the second part of the 3.5 rational applications problems. So we just, in the previous video, we just did the, what were they, the work problems. Now these are going to be the mixture problems. So mixture problems are pretty easy, and in fact, the way that they're written out here, it's like even easier. I've taught this class in years past, and we usually incorporate like a system of equations for these, but it's like stripped down from there, so I'll show you how to do these pretty easily. It says that 11 pounds of mixed nuts contain 28% peanuts. 11 pounds of mixed nuts containing 28% peanuts were mixed with 6 pounds of another kind of mixed nuts that contains 62% peanuts. What percentage of the new mixture is peanuts? So here's how these problems work out. You need one formula that you need to memorize, and that's this. Whatever percentage or cost that you have, like in this case, we're doing percentages. So the percentage of this amount, so amount X, plus the percentage or the cost of amount Y, so in this case it's the 6 pounds of coffee, is going to be equal to the percentage or cost of the total of X and Y, so X plus Y. So here's how these problems always work out. Usually like you get like an amount that these two are equal to, and you have to like kind of solve for the X value and the Y value using a system of equations, but this one's even easier. I'll show you why in a second. So just to kind of follow up, the 11 pounds that we use has 28% of peanuts. So we put the 28% over here, so 28, and then times the amount of that mixture that we're using, which is 11 pounds, so times 11, plus, and then the percentage of the other amount. So we have 6 pounds of the other kind, and that has 62%. So 62% of peanuts in the 6 pounds that we use. That's going to be equal to the percentage of the new mixture, so we don't know that number, so we're just going to put a question mark there of X plus Y. And remember that X is 11, Y is 6, so if we add those together, then we get 17. So, let's just solve this as much as possible. So 28 times 11, that's, I think it's 308 or something. Let's see, 11 times 28. Yeah, 308. So 308 plus 62 times 6, 372. 62 times 6, yeah, 372 is equal to, a question mark. Let's put that as a variable. I've already used X and Y, so let's use like, for percentage, P. Okay, so P times 11 plus 6, which is 17. All right, so we need to solve for the P value. So what we're going to do is just add these two numbers together. So 308 plus 372. So we get, oops, that's not right. I'll just do it by hand. 680. So 680 is equal to 17P. Then if we divide both sides by 17, we get our percentage, which is, let's see, I think it's maybe 40 or something. 680 divided by 17, yep, 40. So 40%. There's our answer. 40% is the percent of the new mixture. So we're going to use that same formula for this problem. It doesn't seem like we're going to because, costs instead of percentages, but it's the same exact formula. Check it out. So 18 pounds of Nicole's special coffee blend was made by combining 6 pounds of brand X and 12 pounds of brand Y, and they have different costs. So you can see that like 6 pounds is going to be one amount, 12 pounds is going to be the other amount, and then we have costs for both of them. So instead of percentages, we're going to put costs in these places instead, and we need to find the cost of the mixture. So watch how easy it is. The percentage of the cost of one of them, so $24 per pound, times the amount of that we put in, which is 6 pounds, plus, and then the amount for the other thing is $9 per pound, so 9 times the amount that we put in there, which is 12 pounds, is equal to the cost of the last one, so we don't know what that is, we'll call it C, times the total, which is 18 pounds, 6 plus 12, so 18. All right, so, just multiply this stuff together. All right, so we have 24 times 6. I'm not going to try to do that one in my head. Wait, it's 144, isn't it? 24 times 6, yeah, 144. Plus, and then 9 times 12 is 108 equals 18C. Let's add these together. 144 plus 108 is 252. And then if we divide both sides by 18, oh geez, I don't know what that is. 252 divided by 18. 14. All right, cool. So 14 on the dot. So that's the cost per pound. So cost is in terms of dollars, so $18 per pound. All right, and that's how you do the mixture problems. See, they're not that bad. Just did both of the ones that are on here. Just remember that it's just a simple formula, and that's all you have to do for it. All right, I'm going to make a separate video for the distance problem, so we'll continue on in the next one.